So these next two questions, 22 and 23 here, are about similar shapes, specifically similar polygons. And as question number 22 implies, that has two parts to the definition, something about the sides and something about the angles that makes the two polygons similar to each other. So I'm going to give you some hints here. Let's say that I trace off polygon A here, this triangle, and I'm going to compare it to polygon B over there on the right hand side. So let me snatch this thing and come on, snatch it. Maybe I group it. Let's see. Group. There we go. And now I can see that the sides are not necessarily the same. They're definitely not the same. But what about those angles? What's got to be true about the angles that match up here? Okay, so the sides I can see are not the same, but usually the way we think of this is like a dilation. So watch what happens when I just increase the size of this. I dilate it basically, then it is going to match up. So that gives us some hints as to what it's asking about corresponding sides and the angles. Okay, so the sides not being the same, not necessarily, they're proportional. So what does it mean when we say that side lengths are proportional? So sometimes when I ask people, hey, what does it mean to be proportional? What they say is, oh, well, it means that they're proportional. That's a pretty good definition, right? So proportional means that they have equal ratios. That's the definition, equal ratios. So as an example, let's say that I give you the ratio 1/2. Looks like a fraction. That's how we sometimes write ratios. Can you give me another ratio that's equal to a half? How about something like 2/4? Okay. Now, the thing that is always true about equal ratios is that the cross products are always the same. So this cross product here, that's equal to 4. And this cross product here, that one's equal to 4 also. So always be true. It is a fundamental property of any proportion. Let's look at another one, because maybe that was a fluke. Let's say that I do, say, 13/26. Do the exact same thing here. So 2 times 13, that's going to be, pretty sure that's 26. And then on the other cross product here, we also get 26. So I'm going to write that down as well. Cross products are equal. Now, that gives us a clue on how it is that we're supposed to solve proportions, and that's what we're going to have to do on something like question number 23. Whenever you set yourself up a proportion in order to solve for specifically the y. Now, usually the way teachers teach this is cross multiply and divide. Now, I tend to say that that's a little bit too simplistic because in our class in honors geometry, we're going to see proportions that are a little bit more complicated that aren't going to be as easy to solve by the method of cross multiplying and dividing. As a matter of fact, since this is 7th grade math and you haven't really learned how to solve equations efficiently yet, this was kind of a shorthand way of solving these kind of equations. So let me give you an example and explain like why cross multiplying and dividing actually works. So let's say that I have 2/3 as a ratio. And then let's say that this thing is equal to, just going to make something up here, x on the bottom, and let's say that this is something like 14 up top. Okay, so now whenever I go to do my cross products, what you have been taught is to cross multiply these two things. So 3 times 14, and then you would divide this by 2. And then of course here is the reason. So 3 times 14, just do this math real quick, over to the side, times 3. I'd have 30 plus 12 is 42 there. I would have 42 is equal to 2 times x. Okay, now if you're going to solve this equation for x, you would, of course, divide this thing by 2. So when I divide by 2, I get x is equal to 21. Now, sometimes you can take a shortcut in solving proportions, because remember what we said is that proportions are just basically equal ratios. So if you can make the fractions the same fraction, then you basically have solved your proportion. So if I look at this example that we're dealing with here, 2 over 3, if I can just scale up this fraction so that 14 is the number that's on top, I would automatically get the number that's on the bottom. And I can do that without cross multiplying by just going, what do I have to multiply 2 by to get 14? It's times 7. And if you multiply the top by 7, you got to multiply the bottom by 7 as well. And essentially what you're doing is multiplying it by the fraction 7 over 7, which is our fancy 1 again. Anyway, up top I would have my 14, and on the bottom there is the 21 that we solved for before. So will that shortcut always work? Yes, it will. It's just that it's not always convenient, because sometimes it's not a nice, neat whole number that you have to multiply this by in order to get your scaled up fraction. So if I change this just briefly here, still 2/3, but make this 15 over x, then you go, okay, so what do you have to multiply 2 by to get 15? Well, it's not a whole number. You can still do it. You'd have to multiply that by 7.5, which means that you'd have to multiply the bottom by 7.5, which isn't as easy to do without a calculator than this method is over here. So in this case, if you can't easily scale up your fraction, then we're just going to cross multiply, set those cross products equal to each other, make ourselves a pretty simple equation that we can solve from there. So that should help you out on both question number 22 and the similar polygons that are on question 23.